Hello, my name is Dylan Chris. The fellow presenters, Lord Dan Jimenez, Josh Hewicki, and Andrew Zahari, are here to present our final design project, which was meant for the River Food Pantry, which was founded by Andy Serkis. But first, a brief history about the River Food Pantry. It was founded to be a public charity organization, and since March of 2006, it has provided food for those who have needed it. Our major goal is to improve the efficiency of their doorway system and improve ventilation and light intake. And as you can see, my bad. As you can see, the current flap system is ineffective, and that in order to properly ventilate the building, one must tie the flaps to the sides, allowing bugs to get in. Other variables, such as human traffic and safety, were major concerns for our design process. Eventually, our team decided to design a door that could be adjusted to the current frame system and behind the overhead door. As mentioned, variables such as human traffic, ventilation, and light intake were considered. Eventually, we evaluated these variables and categorized them into different levels of need. From this, a problem statement was formed. In summary, it describes how our new design will incorporate ventilation with light intake and proper ventilation. I'll now hand this to Dan to properly go through the design process.
Thank you, Dylan. With these concepts in mind, we actually got right to work on our brainstorming process, coming up with solutions that would satisfy all of these conditions. In summary, these conditions are pest control, light, and ventilation, as well as human traffic as a priority. The two solutions that came up were very similar in the fact that they had a top 3 by 10 foot mesh header, as you can see in both of these pictures, but they differed on the bottom portion of the design. One of them featured a double door mesh feature, and the other featured a mat or flaps hanging down of variable different materials. The different materials that we came up with were mesh or plastic. The reason why we ended up going in this direction right here was because this double door was too cumbersome and too expensive to fabricate. So we decided that it was more feasible to go in the mesh flap direction. Our preliminary design was founded by quick brainstorming of different materials that we could have incorporated in the final designs, such as wood and PVC, lumber, and mesh as well. So our preliminary design featured mesh flaps of equal thickness, and it also had that same mesh header that was featured in both the designs that we came up with. So this being said, we actually came up with a final design that featured the mesh header, which was consistent in all of them, with reinforced frames. As you can see, there are 2 frames in between to improve the integrity of the structure, as well as adding frames to the side. So in addition, we also had a pyramid design of flap thickness, where we had bigger flaps on the outside, because most of the clientele is going to utilize the inner parts of the door as opposed to the outsides of the door. So when a client walks through, it's going to leave these big flaps undisturbed, and it's going to achieve the purpose of keeping bugs out, because these flaps will be stationary. In addition, we incorporated the design feature of overlapping these flaps, as you can see right here. We overlap them in such a way that under windy conditions, our door is facing the wind, so that any wind that comes through will leave the flaps generally undisturbed. There won't be any gaps for bugs to get through, essentially. So these all were design features that we came up with to incorporate all of the design specifications. So I'm actually going to hand it over to Josh now to talk about construction and mounting methods.
All right, thanks, Dan. Right now, what we had done, our main materials of use were just galvanized screws, your standard hardware store lumber, and a few pieces of steel to hold all the lumber together. We originally thought of just screwing the different pieces of wood and lumber together, but we decided for added support, since we are spanning a distance of about 10 feet, that adding some steel reinforcement would be a good thing, especially if you had someone hanging on it or a small child or something like that. These are just a couple of pictures up here of some of the reinforcements that we had used. And then our construction, it was really helpful to have the wood shop and having a number of people on the team have the wood shop training so we could go in and use the compound miter saw, which was really helpful. We used that, I believe, for cutting all of our wood. We also used the bandsaw to cut down some of our steel pieces so they would fit a little better. Aside from that, we also used our screwdrivers and just power drills were really helpful, just pre-drilling holes so nothing cracked. We also used staple guns to attach the mesh on the top part of the header. And aside from that, it was pretty simple. It was nice we didn't have to go out or use a very extensive or in-depth different pieces of equipment to make this work. And then this you can see is a picture of our final design. You can see the 3 sections of our top header, as well as how the flaps will look once they're finally hanging down. And we hope that they will do what they're supposed to and keep all bugs out. Along with this, we also had a lot of safety concerns that were brought up by a couple of people. One of them was treated lumber versus your standard everyday lumber. We would have used treated lumber since we're out in the elements. However, we talked to a couple industry experts and we decided that with the treated lumber, galvanized screws would corrode much faster. So we got around this by using standard lumber and just staining it. Along with that, we also were concerned with these flaps and just how much weight we could hold. And for that, I'll turn it over to Ashley.
All right, so one of our biggest concerns as far as safety was how much weight the flaps would be able to hold before breaking. We were concerned, obviously, that young children might pull on them or try and hang on them or something. So you can see our preliminary testing over there, which was just to have one of our team members hang on it and see what would happen, and nothing did, which was nice. So after that, we decided we should probably do some more formal testing, so we contacted the materials lab and did a stress strain test in which 2 jaws pulled apart a sample piece of the mesh, and you can see the resulting graph here. It broke at about 226 pounds. And since that one was only 1 inch wide, and the force that mesh can withstand physically doesn't vary over length, but increases linearly over width, we can extrapolate that number to get the actual weights that would be withstood by the mesh flaps that we have. Obviously, they're comfortably outside any weight that anyone would be putting on these. However, the problem does exist that the attachment points are probably weaker, and it's much more likely that they would rip at the attachment points than in the middle. We weren't able to test that, however, because of the size of the final project and time constraints and budget constraints. A rough calculation was also done to find out the amount of force that the wind puts on a sheet of a given area. That calculation determined that the force would be almost negligible, so we ended up putting plywood in the pockets as weights, but the pockets are still open. It's going to be really easy to add or take out weight as the situation demands. So this is our final budget. As you can see over there, we did go slightly over budget. However, we haven't returned some of the material yet that we didn't use, and even with the extra money, it's still a very cost-efficient and relatively inexpensive solution for the problem. So here you can see our timeline. It's just kind of a chronicle of what we've done the past couple months. And future work, given more time and money, we would definitely want to sew up the weight pouches and finalize a waiting material instead of having to leave it open for the client to decide. We'd also like to test the top mesh portion because we have noticed that heavy weights or significant amount of force does damage it. So maybe if someone throws a ball at it, it might be a problem. We would like to test that, however, because of time constraints, we weren't able to. And we are hoping to go over to the food pantry and to install it. So in conclusion, we'd like to thank our client, the River Food Pantry, for giving us this opportunity. We've all had a lot of fun, learned a lot from this. We'd also like to thank our professor, Professor Rowlands, and our SA Kenny for all their help, and our testing advisors, Bill Lang at the Materials Lab and Ricardo Bonanza at the Wind Tunnel for helping us through the testing process.
So, okay, questions?
Yep.
So how far off the ground is the bottom of the curtain going to be,
Actually,
roughly?
we calculate that it'll only be like a couple inches off the ground.
Not
Okay,
even.
but it won't lay on the ground?
No.
It will be off
It
the
should
ground,
brush the ground,
Okay.
almost.
Yeah.
And just one thought, and I know you couldn't do this unless you tested it with forklifts and things like that, but you want this stuff to be very slippery if a forklift goes through it and doesn't, because it can hold a lot of, it looks like it's very strong stuff, but if a forklift goes through it,
Yeah.
and somehow this gets tangled on a piece of the forklift.
Yeah, our plan was if a forklift needs to come through, because this door is actually not going to be used much for the loading side of things. So our plan would be just to pull the flaps apart if that does arise. It was mostly designed for people in shopping carts.
Okay.
In addition, our mesh is also treated with a very strong resin, so
Okay.
it's
It should be.
nylon and has some plastic on top.
So it's
of it.
quite slippery.
It's, yeah.
Are there any other questions?
Kenny?
What happens to the mesh flaps as a shopping cart goes through? Will it drag over the top or what?
They will actually disperse to the side due to the weighting system. The weighting system will make sure that the center of gravity as the car goes through will push to the side. It won't the car won't actually drag up the flaps. We actually took that into consideration because that was one of our initial concerns having to do with carts. So they'll easily yield and push to the side as they climb, push the cart through.
And in addition, the way the widths were decided, the shopping cart shouldn't be able to contact more than 2 flaps at a time, so there's no chance that one flap will get stuck in the middle and ride up on it.
I'd like to ask you a question. First, I want to thank you for all your efforts.
Thank you.
It's very, 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 very interesting solution to our problem. But what happens with the existing flaps, the plastic material? Does that have to be removed?
Actually, that's entirely up to you. Our perception of it was that our solution was going to be seasonal, that you were going to use the plastic flaps during the winter when you needed to control ventilation, and you were going to use ours when the weather was fair. So.
And would this mount inside the other flaps or outside on the outside of the door structure? Where does it go? Right into the door frame?
It would bound outside. It's designed, when we went to visit, we looked at the structure that's already there and we made the calculations, so it should fit perfectly. Kayla?
So you were saying about the weights, like about the shopping cart going through. Have you decided how much weight is going to be needed so that the shopping cart can go through, or is it just going to flop around?
I can answer that.
Okay.
Like we said earlier, unfortunately, we were unable to test that completely, so we had to go off of logical hypotheses on what kind of weight we would need. Like we said, in our future work, we hope to make that weighting system a lot more integrous and make it more reasonable.
No number?
Currently,
All right, that's all you need to know.
Currently no, but as said before, we have an open pocket on the bottom of each flap as our weighting system. So what is well within the range of possibility, you can adjust weight by taking it out or adding more as need be if you find that it's not working quite as well as it should.
I mean, can you guys, if you guys just held it up in the basement, can you just walk through it? Right? Did
Yeah,
somebody
we
test
did.
that?
Yeah.
Guys, can
We
some of
did
you
that.
guys?
We walked through it.
Yeah.
Mark, you're- Okay.
Okay.
So you tested, you got that number, 4,000 pounds or whatever for the smaller flats. Obviously, if you have something that's 4,000 pounds hanging out, it's gonna break at the attachment point, not the mesh. So what is the weight that breaks at the weakest part?
We weren't able to test that because the materials science lab, when we went over there to talk to them, they didn't have any way, like we talked to Mr. Lang extensively about that because that was our biggest concern. But they didn't have any way that we could test it, and then this was too big to go ahead and actually like test it later on, plus we ran into time problems. So we don't know for that one.
Yeah, Bill actually specifically said, budget of $300 was far too minimal to conduct a test like that. Since we are using pretty, structurally, integrous, materials such as, I think it's steel screws and stuff like that, it should be able to withstand.
And when we discussed it with Mr. Lang, he did say that using the eye plates, which are on this side, to normalize the force, would do a lot to help that out. So we're thinking that it should be all right for small kids hanging on it, but we don't have an exact number.
Basically, anybody big enough to break it is not going to be hanging on it, so.
Okay. Thanks a lot, guys.